Our goal today is to find the area of a triangle on the coordinate plane. Of course, we could always use 1/2 base times height, but that would require a lot of work with some distance formula, maybe point line distance formula to find the altitude. Luckily, we have another method that is a bit more efficient. It's called the shoelace method. You'll see why it gets that name in a second. What I'm going to do is I'm going to stack these 3 vertices, repeating the first one that I wrote. And then the name shoelace comes from the fact that I'm going to multiply on a diagonal. So -1 times 0 is 0. 2 times 3 is 6. 6 times 7 is 42. 7 times 2 is 14. 0 times 6 is 0. And 3 times -1 is -3. You can now see the shoelace type formation. So after I get these numbers, I'm going to add each column. So 14 plus 0 plus -3 is 11. 0 plus 6 plus 42 is 48. And then we subtract these two numbers, which is -37. Obviously, we can't have a negative area in a triangle that exists. So we take the absolute value of that, and we're going to cut it in half. So this ends up being 18.5 for the area of this triangle. Why don't you try the shoelace method on this problem? Pause the video, and when you're ready, play it again to check your work. I got 15 as the area of my triangle. I stacked my vertices, repeating whichever one was written first, multiplied on the diagonal to come up with these 2 columns. Each column I added together, subtracted those sums, and took half the absolute value.